So in this lecture, we'll have a look at how to do forecasting in the linear regression model. We will assume a linear regression model with random sampling and all the Gauss-Markov. The x variables are exogenous, the errors are homoscedastic. As a concrete example, the result on the final for 99 students given the SAT verbal math score and the high school GPA. So we can estimate the parameters using the OLS method. So let's do that here. Linest. It's the final. Then we want to use all three as our explanatory variable. We want to include an intercept and we want the statistics. Alright, so here, and remember it goes the opposite direction. So B4, B3, B2, B1. The intercept, this is the marginal effect of SATV, SATM, and the GPA. So what I want to do now is to predict the final result for a student that's not in our sample. So let's say we have a student and the SATV score for this student is say 520. The SATM score is, let's say, 580, and the GPA is, let's say, 88. So I want to predict what the final result will be for this student. So here's the principle for prediction or forecasting. We estimate the unknown parameters beta 1 through beta k. If the Gauss-Markov holds, then we know that the best way to do that is by using the OLS estimator. And from these estimates, we can forecast y, predict y, given a set of values for x. And the formula we use is simply we plug these x values into the regression model without an error term. So this is the way we calculate the forecast. So what we would do is we would simply take the intercept plus B2 multiplied by the SATV score plus B3 multiplied by SATM score plus B4 multiplied by the GPA score. So this would be the expected final result, our prediction. We predict that the students will score just about 45 points. Another term for forecasts is out of sample predictions. And the reason for this name is that we are trying to forecast or predict a value for y for given values of x that are not necessarily in our sample. So out of sample prediction. If you think you recognize this formula for the forecast, it's probably because you do, because those are just the fitted values. So that means that if I want to forecast the final result for a student in the sample, then my forecast is simply the fitted value for that student. Let's see how to do this in eViews, and in this case I'll use the command window. It's a little bit simpler because it will allow me to easier work with the numbers that the OLS will come up with. You can run OLS directly from the command window, that is without going into this quick estimate equation. And what you do is you just create a new equation. So you type equation, then whatever you want to call it, my equation for example. If you want to create this equation from least squares, then just type .ls. So .ls is what you use to do OLS estimates. And then you can just type in the equation you want to estimate. So final is my y variable. I want to intercept. I want SATB, SATM, HSGPA. Enter. And you can see that eViews has created your equation. So you have the results here. So if you want to do this out of sample prediction in eViews, then one way would just be sort of to copy these numbers and paste them somewhere and then calculate it in Excel or with the calculator or something like that. But it's much easier to just do it in eViews directly. Well, what you need to know in order to do this is how to get to these numbers. And to do that, you need the object reference, because we think of this equation as an object and we need to reference things in that. So just go to help, PDF documents, and the object reference. So you can then find all of them by just going to equation. Here are all the methods for creating an equation, of which the ls is the most fundamental. And further down you have the equation data members. That's what you use to reference the data in an equation. So for example, if you want to reference the coefficients, then you would use this one, coefs, at coefs I. To get to the standard errors, this is the name of the function, at SE, and so on. So what we do is, well, one way of doing this is we can save all the coefficients in variables. So let's save, for example, the intercept in a variable that I'm going to call B1. So I want to create a scalar, and to do that in eViews, to create a scalar, you do coef. Create an equation, you write the equation. To create a scalar, you write coef. Call it B1. You find it inside my equation. This is an object, and to reference things in objects, it's common to use the dot. And that's what we do in eViews. And then you just use the name of the function. To get the coefficient, it's at coefs. And parentheses, which one you want to get to. So the B1, the intercept, is at position 1. Sorry, forgot the equal sign. Coef B1 is equal to this one. You can see that eViews has created a coefficient for you, and this now has minus 35 point something, which is precisely the value of the intercept. We can do the same thing to create the other ones. Just copy and paste. If I copy this one, just change it to B2 here, and 2. And I do the same thing for the third one. And for the final fourth one. If you think this is a little bit clumsy and inconvenient, then you're right. There are better ways of doing that, but that involves vectors, and I will avoid that in this lecture. So now that you have the coefficients, you can just create your forecast as a new coefficient. Forecast. And that should be equal to B1 times, times B1 is the intercept, plus B2, and let's use the same student. So 520, 580, 520, plus B3 times 580 plus B4 times the GPA of our student was 88, like that. So that will be our forecast, and to see it we can just double click this here. 45.62 is the forecast for the final result. Let's just compare that with Excel and we got the same thing. Gretel works very similar, and if you want to do econometrics without going through all these menus, you can just do it through the console instead. So you can open the console from down here. If you want to do OLS, you just type OLS. It has a very useful help command which you can use to see what kind of stuff that you can use. And for example, if you want more information on the OLS one, just do help OLS, and that will give you more information about how to do OLS. But you can see from here, from the example, that it's pretty straightforward. You just type OLS, your dependent variable as 0 for the constant, and then your x variables. So let's do that. Let's do OLS final 0 SATV SATM HSGPA, enter. Right, we have actually capital. Actually, I think I should do OLS with small characters. If you do the up arrow, you can redo it. So let's change it to small OLS. A little bit further, but of course we have capital on these guys, so completely the reverse. Final SATV SATM HSGPA. And now we get the result. So we're again facing the same problem. How do we pull out the numbers from this regression? And in this case, you need to go to the Gretel function reference. So just Google Gretel function reference, and up here you see all the things that we can use. So it's just sort of, it's not that hard to figure out what it should be. COEF seems like the right one to get the coefficient. If you want the standard errors, it's the ST somewhere, STDERR. That's how it gets standard errors. If you want the R square, it's RSQ, and so on. So in Gretel, we would do B1 equal to, the name of the function is COEF, and then you do a parenthesis and the name of the variable. So we simply type COEF const to get B1, and I have done then B2, B3, B4, so I've saved all of them. So we can just do forecast equal to B1 B2 times 520 plus B3 times 580 plus B4 times 88, and the forecast is 45.6 something. Again, same result. There is a quicker way of doing this by using vectors. So what we can do is just put these x values in a vector. I put a 1 for the intercept, then x2 520 580 88, and then I just multiply that by COEF, which will have all the coefficients, and I write something like this in the beginning. matrix forecast equal to should be small like that. And I forgot the $sign on coef. Now hopefully, yes, you get the same result. And this is just the matrix product of this vector here with this coef, entire coef vector, which is this vector of coefficients.